For our next triangle congruence, we're going to look at side angle side triangle congruence. Side angle side states that if two sides and the included angle of one triangle are congruent with two sides and the included angle of another triangle, then the triangles are congruent. So the wording is going to be really important here. So we're looking at two sides. So if you look at this diagram, you can see we have AC and OD, and then a second side, CR and DT. The angle has to be included, and what that means is it's the angle that is formed by those two sides. So that would be angle C in this case and angle D in this other case. So side, angle, side, it's listed in that order because the angle must be between the two sides. And if that exists, then you can say or conclude that the two triangles are congruent by side, angle, side. So in this particular diagram, we've got triangle CAR is congruent to triangle DOT. Don't forget about corresponding parts of congruent triangles are congruent. As long as you prove that those two triangles are congruent, then you can conclude their corresponding parts are congruent and use CPC-TC. Remember, you must prove the triangles are congruent before you can use this. So we're just going to look at three figures and decide if indeed the triangles are congruent by side, angle, side. So for figure A, you can see we have one side that's congruent, a second pair of sides that are congruent. There are no angles marked, but you always want to think about, is there anything in this picture that I can add? If it's got that bow tie look or that hourglass look, you're going to have vertical angles. So we can say that angle OBW and IBG are congruent. And so that is the angle in between the two sides. So these triangles are going to be congruent by side, angle, side. So when we do our congruent statement, we just need to be very careful. I'm going to do BOW is congruent to triangle BIG. Okay, watch the order. For the next one on B, we have a side marked congruent right here. We have an angle, and then we got to think about, is there anything else marked or not marked that we do know is congruent, and that would be this side right here that is part of both triangles, so BM. So yes, these are going to be congruent by side, angle, side, and this would be triangle BOM is congruent to triangle MUB. BOMMUB. Yeah, that's correct. All right, finally with C, we do have a side marked. We also have an angle marked. We don't have anything else marked. However, those two triangles do share a third side. They share AT. So as we look at that, we want to see if that follows side, angle, side. We do have two sides and an angle. However, the angle that we have is not the angle in between the two sides. So these two triangles would not be congruent. So we're going to look at what's given to us and decide the third congruence that we need to prove that these two triangles are congruent using side, angle, side. So we have been given that SA and CU are congruent, so I'm going to go ahead and mark that. That's a side. We're given SY and CE are congruent. There's your second side. So now we have to figure out which angles must be congruent. Remember, it has to be the angle in between the two sides or the angle that those sides form. So AS and YS form angle S. They both have S involved in them. And then EC and UC form angle C. So we would need to know that angle S is congruent to angle C in order to prove these triangles are congruent by side, angle, side. Okay, now we're going to look at a few proofs using side, angle, side. So In this one, we are given JM and LN are congruent. So let's go ahead and mark that. And we'll go ahead and also state that because that was not stated yet. We're also told that angle JMN, so that's this angle right here, is congruent to angle LNM, which is this angle right here. So let's go ahead and state that. JMN is congruent to angle JNM. I'm sorry, I wrote that wrong. That should be LNM. Okay, so we've got a side and an angle. So now if we're going to use side, angle, side, we're looking for another side that we could conclude is congruent even though it's not marked congruent, and that is going to be side MN. It is shared by both triangles, so we know MN is congruent to NM. We know that because it's the same segment, but that's the reflexive property. And now we have enough to prove that triangle JMN is congruent to triangle LNM by side, angle, side. We could conclude also that any part that is not marked would now be congruent because corresponding parts of congruent triangles are congruent. All right, for our second proof, we are told AB is congruent to AD. That's already marked in the picture. That's given to us. And then we're also told that AC bisects angle DAB. So let's look at that a little bit closely. DAB is cut in half is what bisect means. So that means that angle DAC and angle BAC are going to be congruent by the definition of a bisector. And we can be more specific because it's an angle bisector, but it, regardless if it's an angle bisector or a segment bisector, you're still concluding that something is cut in half, and so you're going to be saying that two things are congruent to one another. All right, and what else in this picture can we conclude is congruent even though it's not marked? And that is that side that is shared by both triangles. So that is AC is congruent to AC by the reflexive property. And now we know that triangle ADC is congruent to triangle ABC because of side, angle, side. We have two sides, and then the angle that those sides make is also congruent. So now that the two triangles are congruent, we can prove any of their corresponding parts are congruent. This proof asked us to prove that CD is congruent to CB. And we know that those are congruent because corresponding parts of congruent triangles are congruent, also known as CPCTC. All right, our third and final proof. We have AB is congruent to CD, that is given to us. And we're going to go ahead and mark that in the picture. We are told AB is parallel to CD, also given. So I'm going to put the little arrows. And the other thing that we're given is that D is the midpoint of BE. All right, so let's try to figure out why did they tell us AB and CD are parallel. There's a reason. They didn't just say that for us to write down it's given and not use it. So if I look at AB and CD, they are cut by a transversal BE. And so if we look at the angles formed, we're going to be able to conclude that these two angles right here are going to be congruent because they're corresponding angles. So we know that angle ABD is going to be congruent to angle CDE. Okay, so that was the purpose of them telling us those lines were parallel so that we could recognize that we have two congruent corresponding angles. All right, now let's look at D as the midpoint of BE. Well, why would they tell us D is the midpoint of BE? There's a reason. They don't just tell us something just for us to be like, oh, okay, there it is. There's a purpose. So If D is the midpoint of BE, then what we know is that BD and DE are going to be congruent because a midpoint cuts the segment in half. So that is going to be our next statement. BD is congruent to DE by definition of midpoint. And so now if we look at what we have two pairs of corresponding sides marked. Their included angles are congruent. So we know that these two triangles are going to be congruent by side angle side. So triangle ABD is congruent to triangle CDE. And if those triangles are congruent, then we know their corresponding parts are congruent. So we are specifically looking at trying to prove angle A and angle C are congruent. So now we can state that angle A and angle C are congruent because corresponding parts of congruent triangles are congruent.